Hi, let us talk about the fire resistance of reinforced concrete member. When we talk about the fire resistance, we are referring to the minimum dimensions as well as the assist distance of reinforced concrete member. This is because these two will govern the ability of a member to withstand fire over a specific duration. In fact, Eurocode has provisions for fire resistance of reinforced concrete member. You may refer to Eurocode 2, Part 1-2 about general rules for structural fire design. This is the second part of Eurocode 2, Part 1. The one that you usually use for the design of reinforced concrete member is about general rules and rules for building, which is Part 1-1. Now we're going to look into the Eurocode 2, Part 1-2 regarding the fire design. If you flip through the Eurocode 2, you will see a series of tables providing the values for the minimum dimensions as well as the assist distance for different types of structural element. We have simply supported beam, which can be obtained from table 5.5, continuous beam, table 5.6, one-way and two-way solid slab, table 5.8, columns in table 5.2a and also table 5.2b. There are also others such as flat slab, rib slabs, walls, and etc. From the tables, you will see the values for the minimum dimensions as well as the assist distance. These values are determined empirically from the experience as well as the experimental data under standardized setting, assuming the critical steel temperature of 500 degrees Celsius, a standard 4-hour fire exposure, and also a load capacity reduced to 70% under fire conditions as compared to the normal temperature. Now let us talk about how do you extract informations from those tables. We deal with simply supported beam first. From the table, we see there is a series of standard fire resistance. R30 means 30 minutes fire rating, R60 1 hour, R90 1.5 hours, 2 hours, and so on so forth. You see the numbers here 1, 2, 3, 4, 5, 6. This is referring to the numbers of the column. This is the first column, second column, third column, and so on so forth. We have B mean and also A. B mean means the minimum width of the beam. As for the A, it is referring to the assist distance from the nearest exposed surface to the centroid of the main reinforcement. And then we have this ASD. ASD is different from the A here. It is also the assist distance, only that under certain circumstances, ASD will be equals to A plus 10. As for the column 5 here, ASD will be taken as equals to A, as indicated here. The formula here is only valid for column 2 to 4. As for the fifth column here, that will be the assist distance that you're going to use in the simply supported beam. Let's say now you are designing a beam with 1.5 hour fire rating. That means you are referring to this. There is a series of combinations of the B, min and also the A, giving you different options for you. You may use the beam width of 150 mm, except that you need to provide assist distance equals to 55 plus another 10 mm. Alternatively, you may use 200 mm width with a smaller assist distance. The final assist distance you're going to use, it will be 45 plus 10, 55 mm. What you see here, the larger the width of the beam, the smaller the assist distance is required. And then in the case that you use a beam width of 400 mm, your assist distance need not to be added with additional 10 mm. That means you can simply provide the assist distance of 35 mm, measuring from the side of the beam section. And then if you observe from the table here, there are some numbers with the star. The meaning of this star here, you may refer to the statement at the footnote of the table. To make it simple, when the star is given, it means that the assist distance is relatively low, which at the end of the day, its influence over the cover of the beam sections would be minimal. As a result, you will need to cross-check with the concrete cover, which is the nominal cover that will eventually govern the concrete cover in your finalized beam section. This leads us to the comparison between the assist distance and the nominal cover. Assist distance is meant for fire resistance, whereas the concrete cover here is meant to protect the reinforcement against exposure to the environment. Both have the influence over the concrete cover, except their fundamental principle differs. When we talk about the assist distance, we are referring to the distance from the column face to the centroid of reinforcement. The purpose is to protect the main reinforcement against the deteriorations due to elevated temperature. As for the concrete cover, it acts as the protective layers isolating the reinforcement from the environment in order to maintain the durability of the reinforcement against corrosions. Therefore, the concrete cover, it will be defined by the distance from the edge of the member to the first contact of the steel, which is the shear link. Now, knowing that the assist distance is not the same as the concrete cover, the next thing that you need to know is that they can influence each others. In the typical design process of reinforced concrete beam, you will need to determine the concrete cover required. And then, based on the fire rating, you also determine the assist distance. Since they are measuring at different locations, you will need to do some simple calculations to compare the final cover of the member. If the assist distance ends up to have greater cover as compared to the nominal cover, that means the assist distance will govern the thickness of the cover. And if the concrete cover is greater than what is required as per the assist distance, then the concrete cover shall govern. Coming back to the table, let's say we take this 90 minutes fire rating, 55 mm assist distance plus 10 mm, that gives you 65 mm. That means now your assist distance from the side to the centroid of reinforcement, it would be 65 mm. Minus half of the bar diameter, minus the size of the link. That will be your concrete cover. Compare the concrete cover against the nominal cover that you have calculated using the formula. Whichever gives you the thicker cover, you should use that. The star here indicates to you there is a high chance that for these sections, assist distance will govern the thickness of the concrete cover. As for those with the star, the nominal cover will govern the thickness of the cover. Having this understood, let's say you are dealing with simply supported beam, you may refer to table 5.5. And if you deal with the continuous beam, table 5.6 shall be referred. Again, you will have a series of fire resistant rating that also give you the minimum width and also the assist distance. By referring to this table 5.6, based on the separator of the table here, you know that column 2 and column 3, once you get the assist distance A, you need to add up with additional 10 mm to get the final assist distance. As for column 4 and column 5, whichever assist distance that you have obtained, that will be it. You do not need to add an additional 10 mm as the final assist distance. Next, you want to determine the minimum dimensions as well as the assist distance for the one-way and two-way solid slab. Same, number 1, 2, 3, 4 means the numbers of columns. You have REI 30 to 240 representing the durations of fire exposure. Half an hour, 1 hour, 1.5 hours, and so on and so forth. The minimum thickness of the slabs are given here. The higher the fire rating, the thicker the slab it will be required. And then we have 3 columns here. This is one-way slab and this is two-way slab. Among the two-way slab, there are 2 different groups separated by the Ly per Lx equals to 1.5. If it is less than 1.5, you refer to this column, and if it is more than 1.5, you refer to this column. Exceeding 2.0, then that will be the one-way slab. Especially the definitions of the one-way slab, try not to get confused with. There are 2 circumstances where a slab can be one-way. First is due to the arrangements of the beam. When a slab is supported by beams only on 2 sides, it will be one-way slab as presented here. There is another type of the slab where you have beams in all 4 sides as represented here. We will look into the aspect ratio by having the Ly per Lx. If the Ly per Lx is less than 2.0 and when it is supported by the beam in all 4 sides, then that will be two-way slab. And when the Ly per Lx is more than 2.0, it is considered one-way slab. And in the case that you have beams only on 2 sides, it is also the one-way slab. And then how do you define the assist distance A? We are referring to the soffit of the beam to the centroid of the tension reinforcement. which is the main reinforcement. If you read the table carefully, you will observe the axis distance that you have obtained. There is no need to add up an additional of 10 mm, like the one we see in the beam. That's why Eurocode provide you a diagram, something like this. In their definitions, ASD is referring to the side of the member, whereas the A is referring to the soffit. In the case of the slab, we have only the A, but not ASD. Therefore, whichever value that you have obtained for the axis distance for the slab, that will be the value governing the cover of the slab. There is no need for you to add up an additional 10 mm in order to acquire ASD. Also, you see the star here. That means under these circumstances, the nominal cover is more likely to govern the final thickness of the cover for the slab.